In this problem, we are asked to find an equation of the perpendicular bisector of the line segment whose endpoints are given, and they are 2, -1, and -4, 1. So the first thing we have to do is perpendicular bisector means it bisects the line segment, so it's going to go through the midpoint and it has to intersect perpendicular to the given line segment. So first thing we're going to do is find the midpoint. Well, we know that the midpoint is found by adding the two endpoints, the x values and dividing by 2, the y values and dividing by 2. So I end up with a point of -1, 0 as our point where the perpendicular line passes through it on this line segment. So my next step is, now I have the point that it passes through. To generate a line, I need either 2 points or a point and a slope. So now I'm going to look for my slope. So to find the slope of a line perpendicular to the line segment, I first have to find the slope of the line segment. So I'm going to find the slope of the line segment. Well, I know slope is change in y over change in x, or y2 minus y1 over x2 minus x1. So I substitute my values, and I end up with the slope of the line segment equaling -1/3. But that's not the slope I want to use in my answer. I want to use the slope perpendicular to that, which means I take the negative reciprocal of -1/3. So the slope of the line perpendicular to the line segment is going to be a +3 over 1, which is 3. So I'm going to use the slope of 3 and the point of -1, 0. So using that information and the point slope form given here, I can find the equation of the bisector, the perpendicular bisector. So I substitute in the value for m, substitute in the value for my point, do some calculations, and I end up with y equals 3x plus 3, or if I want it in general form, I can rewrite it as -3x plus y equals 3. So the first case is slope-intercept form. The second case is general form. And that is the solution of the perpendicular bisector to the line segment.